All right, two more theorems in this section. Parallel proportionality theorem says if three parallel lines intersect two transversals, then they divide the transversals proportionally. That's pretty much been the fill in the blank on every rule so far. Proportionally. So we can set up a proportion if this is happening. They have UW over WY, and what would match with that would be VX over XZ. Sometimes I describe these as like ladder problems because it looks like a ladder, but it's breaking them proportionally. You could also put UW over VX and WY over XZ if you wanted to in the picture. The second theorem here says that if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So proportional again. In this, so this theorem is going to be used for these bottom ones, and this theorem is going to be used over here to the side. So determine the length of each segment in this picture on the right. They want BC, FC, GB, CD. Be careful when you're finding the bottom of these triangles because you can do the proportion for the sides, but if you're using the segment here, like to find FC, I'm going to need to add these two sides together to use 10. So if I was to do that one right now, well, I would need one of these bottom lengths. And I do have that one here with the 15. So I'll have to use the entire side in the 15 and then like 5 in X here, or the entire side in the 15 and 10 in this one. So I'm going to start by finding BC. I'm going to put just a variable there for BC. Setting up my proportion because my parallel sides here, I'm going to have 5 over 5 equals 6 over x, cross multiplying 5x equals 30, and dividing x is 6. So that means that BC would be 6. And you can label it and you can use that for a future problem if you need it. They do want CD as well. To find CD, I could do 5 over 7 and then 6 over x, using that 6 to find this one. So now I called that x again, but you could make up different letters, whatever's fine. 5 times x equals 6 times 7, so this one's going to be a decimal answer. 6 times 7, 42. So 42 divided by 5 is 8.4 for that side piece there, and so that's CD. Working out of order a little bit there. Okay, and then if I want to find GB, for example, so I'm going to call that Y since I've used X so much already. To find that, I need the side to the bottom, and since this is having nothing to do, well, I mean, it's proportional because of these parallel lines, but I'm not using the side pieces, so we need to use the entire side to bottom, which would be 5 to Y, and then the entire side, the only bottom we know is the 15, so I need the entire side. So if I'm going all the way across the side, that's 17. So side to bottom would be 17 to 15. And then cross multiplying there, so it would be 5 times 15 is 75. 17y cross multiplying the other way, and then dividing that by 17 is 4.41. So that's GB. And you do get a lot of decimal answers with these, so if you are getting that, it's, you know, don't necessarily be concerned. And then to find the other one, again, I'm going to use a 15 because I'm not going to be using this decimal answer. I've rounded that anyway, so it would mess things up. I'm going to put 10 over, I'm going to call that Z, so that's side to bottom equals 17 to 15. side to bottom again. 10 times 15, 150. 17z, 150 divided by 17 is 8.82 for z, for the other piece that we were missing. And now we found all of those. So the other type of problem is that bisected angle problem. And it says that if your angle is bisected, then the side it's dividing is proportional with the sides that are there. So let me see how they had done it for theirs. AD. Okay, so what they did was they have, like, if I were to put this number over this number, then I would put that's equal to this number over this number. But with these, there's a lot of ways that you could set this up. I often like to do side to part of bottom that is with it equals side to the part of the bottom that's with it. But I'm going to show you how, like in their rule, which I didn't finish, by the way, is they had AD over DB, which you can see as the pieces of this side. And then since AD was first, AC would be over here, and CB. So using that rule, if I put 3 over 3, which this one's obvious, and then x over 6, then obviously, you know, cross multiply, or you can see these match, so these have to match. X is 6. Again, you could put 6 over 3. This is what I like, is the side part to the bottom that is next to it, and then x over 3. And again, there you could get x is 6 as well, so you could work that either way. So moving on to the next one here. If I want to use their rule, it would be x over 8, 9 over 12. I really like to do 12 over 8, 9 over x, because just, I don't know, I like the way that looks better, and it gets me the same answer. But again, you could do either one. 12x, 8 times 9, 72. Dividing 72 divided by 12, 3.27. Would be the answer there. And then the last one, if I put 6 over 3, or I could do 3 over 5, 6 over x, really lots of options. Piece of the bottom, side that is next to that, side that's next to that one. Cross multiplying, 3x is 30, x is 10. These are easy once you get the hang of those rules, especially the angle bisector one. 4, 4, so I'm not even going to set this up. If these are matching, these will be matching. X is 8. Here is one of those ladder problems. If these angles are matching, their corresponding angles, and by the converse of the corresponding angles theorem, or corresponding angles converse, you know that these lines are parallel. And then you can set up 2 over 3 x over 3.5. And so you can cross multiply that. 2 times 3.5 is 7. 3x, I'm going to get a decimal again. So 7 divided by 3 is 2.3 repeating, 2 1/3 is x there. So that's how to use those proportionality theorems.